Below is a Bohr model representation of the hydrogen atom with several electron transitions depicted by arrows. Rank the absorptions in terms of decreasing wavelength and the emissions in terms of increasing energy. Okay, so first of all, we got to figure out which ones are absorptions and which ones are emissions, right? So let's just put down here absorptions and then emissions, right? So under absorptions, we're going to find anything that goes from a low energy level to a higher one, like this B here. This one's going from 1 up to n equals 3. So B is an absorption. E is also an absorption from 1 to 2. So E is an absorption. A and D are emissions because they're going from higher to lower. So A and D. F is an emission as well. G is an absorption. It's going from 2 all the way out to n equals 6. That's G. And then H is also an absorption. It's going to be excited from this n equals 2 level all the way to n equals 5. So there's H. All right, so there's all of our emissions and our absorptions. Did I get them all? What about C? I didn't do C. C goes from n equals 2 down to n equals 1. So that's going to be an emission. So C goes here. So we have 4 of each one. All right. Now, what we need to do is figure out, I think the easiest way to go about this is to just figure out which ones have the highest energy and which one have the lowest energy, okay? So we can just start with A here. A goes from n equals 6 down to n equals 5. So if we have 6, 5, 4, 3, 2, and 1, like this. So from 6 down to 5, right? That's going to be a pretty small energy. So this is just giving us the energy here. The next one is B, goes from 1 up to 3. So 1 to 3. Oops, I'm going to draw this way. There we go. That's a pretty big one, right? That's a large one there. So B is very large. A, pretty small. C goes from 2 down to 1. So let's go from 2 to 1. That's C. D goes from 4 to 2. So 2, 3, 4, down to 2. So that's D. E goes from 1 up to 2. That's E. F goes from 6 down to 3. From 6 to 3. And that one is F. All right. Then G goes from 2 all the way out to 6. 2 all the way to 6. That's G. And the last one goes from n equals 2 to n equals 5. From here all the way up to here. Okay. And that's H. All right, so let's look at these. And, I'm going to go ahead and kind of mark the ones that are absorptions with red and leave the emissions as blue. So this is an absorption, and we have an absorption here, and an absorption here, and an absorption here. So those are our 4 absorptions. We look at these, which one has the longest line? Well, B does. So B has the largest, so let's just put this in terms of energy. Okay. B has the largest energy. Then it looks like E would be the next largest. And then these two both start on 2, but G goes a bit further. So G is larger than H. Okay. Why don't we go ahead and rank the energy of these other 4 as well? Let's go with the energy for the emissions. So C looks to be the largest of these four, right? 1, 2, 3. Where's my fourth one? Oh, 4. There it is. A little tiny A. I'm going to say A is all the way at the end. It's the smallest one for sure, right? But it looks like C here is our largest energy. And then D, it looks larger. Well, it's definitely larger than F. So D, and then F, and then A would be the smallest. Okay. So so it says to rank the absorptions in terms of decreasing wavelength. All right. So these were our absorptions, and we have it in order of decreasing energy. But what we know is that in terms of wavelength and energy, E is equal to hc over lambda. Okay, and so they're inversely related, which means then that we would have to go for decreasing wavelength. We need to start with h. I'm going to put a lambda here. Okay, h is going to be the largest wavelength, and then g would be a little bit smaller than h. E would be a little bit smaller than g, and B would be the smallest wavelength, right? For the emissions, it says in terms of increasing energy, and well, we have it in the opposite order, so we can redo this and say that it's going to be that A is smaller than F, which is smaller than D, which is smaller than C. So increasing energy, right? And this. And that's all we had to do. All right, guys, thanks a lot.